Today we're going to start talking about our factoring unit where we are basically doing the inverse of what we have already been doing. You have been adding, subtracting, multiplying, and dividing polynomials. And today we're going to talk about how we do the inverse of multiplying a polynomial. So if we write our heading today, we're writing our own notes. So make sure you have a piece of paper on your desk. So today I'm going to be factoring polynomials. Okay, so let's first review by putting a problem on the board. So I know I have to distribute this problem because I have one set of parentheses and the 2x is sandwiched on the outside. So I'm going to distribute 2x to every term inside. So 2x times 3x squared, so 2 times 3 is 6. X and x squared make x cubed because 1 plus 2 is 3. Plus 2 times 5x, 2 times 5 is 10. X times x is x squared. Plus 2x times 1 is just 2x. And I know I'm done because I can't combine any of my terms. So my goal with factoring is the inverse of this. I'm going to give you this, and I want that. So the question is how do I do that? That's my goal. Because everything in math has an inverse, has an opposite, and so that's what I'm doing when I'm factoring polynomials. So my first question I'm going to ask today is, what is a factor? You've seen this word factor a lot in your mathematical education. Does anybody know what a factor is? A factor is just a number that is divisible by another number. So if I'm thinking about the number 4, a factor of 4 would be 2, because 2 goes into 4. So if I look at it, I think about the number 12. Give me a factor of 12. Well, 2 and 6. All right. What is another factor of 12? Another factor of 12 is 3. And what's another factor of 12? 4. And what's another factor of 12? Well, 12 is a factor of 12. And a factor, and there's one more, 1. And the nice thing when you're listing factors is all those numbers multiplied to 12. 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12. So those are all factors of 12. So now, let's try another one. How about 10? You list all the factors of 10. What are all the different factors of 10? Well, 1 and 10, obviously, and 2 and 5. Those are all factors of 10. So now we know what a factor is. So before I can actually get into the nitty-gritty details of talking about factoring the inverse of distributing, we have to talk about what a GCF is. So now let's talk about, well, what is a greatest common factor? We call that a GCF. So now I want to talk about the greatest common factors. So as you're writing this, I'm going to write down the factors of 12 and 10 again, since I erased them. These are the factors of 10 and 12, even though 10 is doing a great job with the use of technology here this morning. So now if I want to know the greatest common factor, I want to know out of these numbers and out of these numbers, what's the biggest number they have in common? Well, the biggest number they have in common is 2. So in this example, my GCF would equal 2. So what if I did what if I did 12 and 18? So I already have the factors of 12, so I'm going to cheat and write them again so I don't have to think of them. All right, and now 18. What are my factors of 18? Well, 1 and 18 2 and 9, and 3 and 6. So what's the GCF of 12 and 18? Well, my biggest number that goes into 12 and 18 would be 6, because that's my biggest number. So now, ladies and gentlemen, finding the greatest common factor is just half the battle. It's only half of what's going to get you to be able to do the inverse of distributing. So we want to be able to do all of this quick. Ideally, you want to do all of this in your head. My advice when you're doing this problem is you start with the smaller number and you think about the biggest factor that can go into it. So at 12 and 18, the biggest number that can go into 12 is 12. 12 can't go into 18. So now I'm going to think about the next biggest number that can go into 12. The next biggest number that can go into 12 is 6. Well, hey, 6 goes into 12 and 6 goes into 18. I'd be done. So let's do it that way here. If I try 24 and 16, I want to find the GCF without showing any work. So I'm going to start with my smallest number, 16, and I'm going to say, okay, what's the biggest number that goes into 16? What's the biggest factor of 16? Well, 16 is. Can 16 go into 24? No. All right, so what's the next biggest number that goes into 16? 8. Well, 8 goes into 16 because it's a factor. Can 8 go into 24? Yes, it can, so my GCF is 8. Your goal is to be able to do this as fast as you can, because this is only half the battle. So now I want you to pause this video and I want you to try 10 and 75. I want to know what the GCF is. Pause this video when you think you have the answer. Unpause this video. Alright, 10 is my smaller number. You always start with your smaller number. What's the biggest number that goes into 10? 10. Alright, can 10 go into 75? No. Okay, what's the next biggest number that can go into 10? 5. Well, can 5 go into 75? Sure enough. So my GCF is 5. Okay. So algebra is the study of variables. So what about variables? If I have x squared and x cubed, and I want to know the GCF, well, I have 2 x's over here, and over here I have 3 x's. How many x's do they both have in common? Well, they both have 2 x's, so my GCF would be x squared. Okay? So if I scroll and we look to another one, if I do y to the 4th and y to the 7th, here I have 4 y's. Here I have 7 y's. How many y's do they have in common? Well, this has 4 y's. Does this one have 4 y's? Sure enough. GCF is 4 y's, which is y to the 4th power. And if I do one more, z to the 6th and z to the 3rd, how many z's does this one have? 6. How many z's does that one have? 3. So what's the biggest number of z's they both have in common? 3. So have you noticed any relation between your GCFs and what you're given? Notice x squared, that's the smallest exponent in those problems. With x to the 4th and y to the 7th, y to the 4th is the smallest exponent. With z to the 6th and z to the 3rd, z to the 3rd is the smallest, so it wins. So my trick, and we'll write this down so we have it here. My trick is the variable for the GCF is always the smallest exponent. So that's going to save us a lot of time when we're having to do this. Again, remember, this is just half the battle. So now, we're going to put the two things together. I'm going to give you 14x squared and 35x to the fifth. And I want to know what the GCF is. Okay, so I'm going to look at the numbers first, 14 and 35. Remember my trick? You start with the smallest number, so 14 is the smallest number, and you ask yourself what's the biggest number that can go into 14. Well, 14 is the biggest number that can go into 14. Can 14 go into 35? No. All right, the next biggest number is 7. 7 can go into 14. Can 7 go into 35? You betcha. So 7 goes here. And now I'm going to look at my variables. X squared and x to the fifth. I'm going to do my trick. The smallest exponent is x squared. So 7x squared would be my GCF. If we do one more before we start putting it together. What if I did this? Actually, I'm going to do 2 more. Let's do 42x to the fifth. Whoa, that's a horrible number. X to the fifth, y to the third, and 16x to the fourth, y squared. I want the GCF. All right, you start with the smallest number. What's the biggest number that can go into 16 is 16. 16 cannot go into 42. If you don't know your numbers, use your calculator. 42 divided by 16, that's not going to work. Next biggest number that goes into 16 is 8. 8 does not go into 42. Next biggest number of 16 is 4. 42 divided by 4? Nope, that doesn't work. So the next biggest number is 2. Can 2 go into 16? Yes. Can 2 go into 42? Yep. So now we treat each variable separate. X to the fifth and x to the fourth. My smallest exponent is x to the fourth. Y to the third and y squared. My smallest exponent is y squared. And I'm done. If I look at one more, if I were to do 4x squared and 12y squared, let's find the GCF. First thing I'm going to do is look at my numbers, 4 and 12. Start with your smaller number. 4. Can 4 goes into 4? Can 4 go into 12? Yep, so my GCF is 4. So now look at my variables. This has x squared, this has y squared. The C in GCF is common. Do they have anything in common? No, because this one has an x and this one has a y. So my GCF here would just be 4. So now, if I were to have 5x and 7y, the only factor of 5 is 5 and 1. 5 doesn't go into 7, so the only number they have in common is a 1. X and y, do they have anything in common? Nope. So my GCF in this case would be 1. So now here's the main punch of my day. How do I undo distributing? Here's the main lesson, the main punch of where I'm trying to get to. How do I undo distributing? Well, I have 3 steps. Step 1, find a GCF. We've just done that. Step 2, divide every term by the GCF. Step 3 is I want to write answer in distributing format. So remember, distributing looks like this. So the number on the outside is my GCF, and the numbers on the inside are my leftovers after I divide. Okay? So, we take a problem here. and we look, let's work forwards and then we'll work backwards. 5x times 4x squared plus 3. And everybody pause this video and solve this problem for me real quick. 5x times 4x squared is 20x cubed. 5x times 3 is 15x. So now I'm going to take my answer and I'm going to work backwards. I'm going to take my answer and I am going to undo distributing. So this is what it's going to look like over here. So step 1, I'm going to find my GCF. So 20 and 15. You start with the smallest number, 15. 15 can't go into 20. The next smallest factor of 15 is 5. 5 can go into 20, so okay, 5. And the smallest exponent wins. X cubed and x. So I found my GCF, that's step 1. Step 2, I'm going to divide every term by my GCF. So 20x cubed divided by 5x, so 20 divided by 5 is 5. X cubed divided by x is x squared, because 3 minus 1 is 2. Plus 15 divided by 5 is 3. My x's cancel out. So now I have to write it in this format. My leftovers are in the parentheses. My GCF is on the outside. And notice this looks exactly like the problem that I started with. Okay? So let's go ahead and do another one. 16c to the 7th minus 6c to the 3rd. So the first thing I'm going to do is find the GCF. When I'm finding the GCF, I ignore the positives and the negatives for now. So 16 and 6, what's the biggest number they have in common? So 6 can go into 6, 3, 2, and 1. So the biggest number is 2. And c to the 7th and c to the 3rd, GCF would be c to the 3rd. So now I'm going to divide everybody by my GCF. So 16 divided by 2 is 8. C to the 7th divided by c to the 3rd is c to the 4th. 6 divided by 2 is 3. That's a minus sign there because I just brought it down. C cubes cancel out. Your leftovers go in parentheses, and your GCF goes on the outside. Why I have to write my answer like this is because your problem, you are undoing distributing. So your answer has to look like a distributing problem. If I wanted to check my answer, all I would do was distribute. All I would do. So let's do one more together. 8y to the 5th minus 12y cubed plus 16y. So here I have 3 terms, so when I'm finding the GCF, they better have it in common with all 3 terms. So 8, 12, and 16, 8's my smallest number. 8 can't go into 12, so my next smallest factor of 8 would be 4. 4 can go into 8, 4 can go into 12, and 4 can go into 16, so that's my GCF there. So this has y to the 5th, this term has y to the 3rd, and this term has a y, so they have a y in common. So now, I'm going to divide everybody by my GCF. So, 8y to the 5th divided by 4y, so 8 divided by 4 is 2. Y to the 5th divided by y is y to the 4th. 12 divided by 4 is 3. Y to the 3rd divided by y is y squared. Plus 16 divided by 4 is 4. My y's cancel out. I cannot leave my answer like this because it doesn't look like a distributing problem. My answer has to, my leftovers are in parentheses. And who do I write on the outside? My GCF, 4y. And I'm done. Typically, when we have problems, we always want to get rid of parentheses first. When I'm factoring just means my answer has parentheses, which we're going to write down. Factor means answer is in parentheses. All the directions on these problems are going to say factor. So your brain needs to remember that when you see the word factor, you know you have to put it in parentheses, and how you do that is by taking the GCF. So I'm going to give you this problem, and you're going to pause this video, and you're going to solve it on your own. 14z to the 8th plus 24z to the 7th minus 30z cubed. You're going to solve this problem, and you're going to unpause this video, and then we're going to go over it. If we go ahead and go over this together, the one thing that I would like to say is a lot of people like to cut corners and not show work. I'm okay if you don't show work and you want to try to do this in your head. That's fine. So the GCF between 14, 24, and 30. 14, 24, and 30. So 14 is my smallest number. 14 does not go into any of them. Excuse me. 7 doesn't go into any of them. 2 goes into them all. So 2 is my GCF, so I'm going to put 2 out here. Z to the 8th, Z to the 7th, and Z to the 3rd have a Z cubed in common. So now I'm going to go ahead and divide everybody by Z cubed. And again, if you can do this in your head, go for it. 14 divided by 2 is 7. Z to the 8th and Z to the 3rd is Z to the 5th. 24 divided by 2 is 12. Z to the 7th and Z to the 3rd is Z to the 4th. 24 divided by 2 is 15, and my Z cubes cancel out. So if you do it that way, you can then do this and erase. One thing I really want to stress is that the directions are going to say factor. Okay? So we're going to pause here, and then there'll be a part 2 of factoring with the GCF. Do what either you can watch it now, or you'll do what is asked of you to do.